the shuffled anagrams. Let S be a string containing only letters of the English alphabet. An anagram of S is any string that contains exactly the same letter as S with the same number of occurrences for each letter, but in different order. For example, the word cake has anagrams such as this one and this one. Now let S of I be the ith letter in S. We say that an anagram of S A is shuffled if and only if for all I S of I not equal A of I. So for instance, this word is not shuffled anagram of cake, as the first and fourth letter of both of them are the same. However, this word would be considered a shuffled anagram of cake as with this word. Given an arbitrary string S, your task is to output any one shuffled anagram of S, or else print impossible if this cannot be done. So here we have two test cases. The first one is this word start, and this is the solution for a shuffled string from the start, and that is because the number of each character in the two words are equal, and also the index of each character is different from in each word. So here we have one S, here we have one S, here we have two T, here we have two T, here we have one A, one R here, and one R here. And also the index of S here is 0, and here it's 4, so they are not equal. The index of T is 1 and 4 at the original string, and here it's 0 and 3, so they are not equal. The index of A is 2, the index of A here is 1, so this is a solution. Now for this string it's impossible, so we print impossible because we have 3 characters of the same value. Now how to solve this problem? Let's take an example. Here A, B, C, B, B, and C, B. First of all, we need to count the occurrences for each character. So for A we have one character, for B we have 1, 2, 3, 4, for C we have 1, 2, and the maximum occurrence for any of these is 4. This string length is 1, 2, 3, 4, 5, 6, 7. 7 characters, and here we need to divide 7 by 2, which is half of the length of character, equal 3, and here the max is greater than 3, and this will tell us that it's impossible to have a shuffled array. So as long as the maximum number of occurrences is greater than half of the length of the string, it's impossible to get a shuffled string. And this is because if we need to schedule the letter P into other indexes, because in the question we need to every index or every letter should exist in different index in the shuffled array, and if we want to schedule the letters B, we can bring this to one of these locations, this one, this one, this one. So if we added b here and we added b here, then we added b here, it's impossible to schedule the last p into any location that's not p. This is why it's impossible. So if any of the letters occurrences is greater than half of the length of the string, it's impossible. So this is part of the first part of the solution. Now if it's possible, we need to print the candidate or the answer, and to do that, first of all we need to sort the string. Before that, let's make it possible. So let's remove some of the p's. So our string is a, b, b, c, c. Now here we have 2 characters from b, 2 characters from c, 1 character from a, and the length of the array is 5. 5 divided by 2 equal 2, and there is no character that has occurrence greater than 2, so it's possible to shuffle this array. First of all, we need to sort it. So here we have a, we have b, then we have b, then we have c, we have c. It's already sorted, but assume if c is here and b is here, so after sorting it become a, b, b, c, c. Then we need to shift it by half of the string. So here we have 2, so we need to rotate it to the left, so this character become here, so it's b, c, c, a, b. Now after doing this shifting, it can be shown that every character is different than the character in the shifted array or the rotated array, and this will help us for the solution. So for every occurrence of a, let's take one of the a's here in the string and we replace it with p. Then we go to one of the b in the original string, and we replace it with a c, and then we replace one of the b by c, and we replace one of the c by a, and we replace one of the c by b. So this will be our solution. As you can see, it's shuffled, contains the same number of characters, and every character in a good index. And this is the implementation. So here we are looping over the test case, and this is our function. First of all, this is the size of the string. Then we need to store the occurrences for, or the indexes for every character. So we have this dictionary that will map character to a vector of indexes, and while looping and pushing indexes for each character, we will also calculate the max count for every character to see if it's possible or impossible, and if the max count is greater than n divided by 2, it's return impossible. Now here we need to sort a string, and here we need to shift the sorted string by by half of character, or by half of the length of the string. We shift it to the left, or we rotate it to the left. So now we have sorted the string, and we have the shifted string, and we proved that every element does not match with so every element or every character in the sorted array does not equal the element in the shifted array. Then we need to loop for all the character, and we will start assigning the values. So here S of indexes of sorted, S of I. So this is the character at index I in the sorted array. We need to replace it in the original array by a character in the rotated array, and we need to pop from the vector, so that we know that one of the element is already covered.